Hello everyone. Today we will mention about shear and bending moment diagrams. We use universal sign convention to find shear, normal and bending moment values. Shear force is shown with V, axial force is shown N, bending moment is also shown N. We will start with the single load. First of all, we have to draw free body diagrams to calculate our reactions, and then we will draw our shear moment diagrams. Now we will draw our free body diagram. There is a pin support at A and also roller at B. 6 meter beam, 9 kilonewton, single load. First step, the question wants us to draw the free body diagram. Okay, let's start. We have pin, therefore, we have two reactions, EY and EX. Also, there is a roller here at point B. Roller gave us only one reactions, which is BY. And also 9 kilonewton single load here, 4 meter, 2 meters. Okay, draw free body diagram is completed. Then find the reactions. How can we find the reactions? We use equilibrium equations to find reactions. First of all, total Fx equals 0. It means Ax equals 0. MA or MB equals 0 we can take. Counterclockwise is positive given. Uh, Therefore, minus 9 times 4 plus by times 6 equals 0. Hence, we can calculate by 6 kilonewton here. And the final step, we calculate total Fi. Total Fi equals 0. As a result, Ey minus 10 plus By equals 0. We put here 6 kilonewton, then we find Ey is equal to 3 kilonewton. Okay, part B is also completed. Now part C. Draw V and M diagrams. V is shear, M is bending moment diagrams. First of all, we start with the By. We know Vy is equal 6 kilonewton. Sorry, Ay is equal to 3 kilonewton, By is equal 6 kilonewton. Now start with By. We draw it with green. Okay, 3 kilonewton. Then, is there any force about around 0 to 4 meters? There is no force, hence we move it constant. And also, there is here 9 kilonewton to the down and 9 kilonewton to down. Then 2 meter, there is no force here. Okay, let's start with the values. 3, here 3 minus 9 equals 6. Here is positive, here is negative, here is minus 6. Then there is By here. By minus 6 plus By equals 0. It is important to close here or reaching 0 is important. Now we will use these areas to draw bending moment diagram. Here is the first area. We can say A1. We can say A2. A1 is equal 3 times 4, 12, 12 kilonewton meter. It means 12. Then it will reach 0 because A2 is equal minus 6 times 2 meters minus 12. Hence, total A equal also must be 0. starts from 0, finished at 0. And this is our first example. Our steps are, first of all, we draw free body diagram. Secondly, finding reactions from free body diagram. And the final step, we draw shear and bending diagrams. Another example, now at this example, we have two single loads. Uh, Also, there is two supports which are again the same. A is pin, B is roller support. Uh, Part A, we draw our free body diagram. Okay, let's draw. Here, there are two reactions, EY and EX. Also B, there is BY. There is 10 kilonewton single load. Also another 10 kilonewton single load. 2 meter, 6 meter, 2 meter. Free body drawing is completed. Find the reactions. Total Fx equals 0. Total Fx equals 0. Ax is equals 0. Second of all, Ma equals 0. Counterclockwise, I assume positive. Minus 10 times 2. Minus 10 times 8. Plus By times 10. As a result, By equals 10 kilonewton here. At final equation, total Fy is equal 0. It means Ay minus 10 plus By equals 0. We put here 10 kilonewton. As a result, Ey is equal to 10 kilonewton. Okay, let's draw our shear moment diagrams. First, we start with shear. There is Ey here, which is 10 kilonewton. By is here, which is 10 kilonewton. It is a symmetric beam, hence the results of our support reactions are equal to each other. Here we start with 10 kilonewton. Then there is no force or distributed load or moment here during 2 meters. Then we put 10 kilonewton down. Here along 6 meter there is no force. Then we will put down 10 minus 10 also. Here we go again. There is no 2 meter force. It moves constant. As a result, finally we reach 0 with By 10 kilonewton. It is plus, it is minus. Positive and negative means positive moment here, negative moment here, or minus moment here, we can say. When we want to draw bending diagram, we start with the area. 2 meters times 10 it equals 20. And it moves direct 1 degree, yeah, y equals mx condition. And it moves 20, 1 degree equation here, linear also we can call. There is no area here. Minus 10 times 2 minus 20, it reaches 0 here. We can say Mmax 20 kilonewton meter at x equals 2 to 6 meters. For Vmax, 10 kilonewton at 0, 0x2 and 8x 10 meters. Why did I write this? Because these values will use at mechanics of materials to find the value of bending stress and also shear stress. Mechanics of materials is the next course of statics. We complete our three parts: draw free body diagram, finding reactions, and also draw VM diagrams. We have another question here and the same questions for parts ABC. First of all, we start with the free body diagrams. We use FBD, FBD is called 5 kilonewton here, EY, EX, 10 kilonewton here, 2 meters, 2 meters, 2 meters, 2 meters, BY here due to roller, and also 5 kilonewton here. Okay, let's start with single load at minus y direction. As a result, we start with 0 to minus 5. Okay, let's start. 0 to minus 5. Then there is no force along 2 meters. Also, there is EY here. We don't know EY, but we can calculate it. Total Fx equals 0. Hence, Ax is equals 0. Ma equals 0. It means if we take moment with respect to point A, 5 times 2 minus 10 times 2 plus By times 4 minus 5 times 6 equals 0. By is equal 10 kilonewton. Total Fy equals 0 minus 5 Ey minus 10 By minus 5 equals 0. Ey is equals 0. 10 here. Then we wrote it. There is force here in y direction. As a result, it moves in positive y direction. Minus 5 plus 10 equals plus 5. There is no force along 2 meters. Here 10 kilonewton to minus y direction. It means 5 minus 10 equals minus 5. Uh, there is no force along 2 meters. There is By here. Minus 5 plus 10 equals 5. And there is constant move here. And also 5 meters down. Minus, plus, minus, plus. Okay, let's start our final bending moment diagram. All lengths are equal and 2 meters. We can write here 2 meters. All of them are 2 meters. Now, first area is minus 5 times 2. It equals minus 10. It means minus 10 is here. Also, there is area 2. 5 times 2 equals 10. Minus 10 plus 10 is equal 0. 0 here. Another area, minus 5 times 2 minus 10. It is here, minus 10. And the final area, 5 times 2 will equal 10. Hence, it will go 0 again. Today, we mentioned about VM diagrams. First of all, we draw free body diagrams. Second of all, we find all reactions. Third of all, we draw V diagram, which is shear diagram. Then finally, we draw diagram M, which is bending moment, the bending moment diagram, where we find area at V diagram. Okay, we start with universal sign convention. Then we solve three examples. Today with single laws. At another chapter, we will continue with the distributed load conditions, how we draw V and M diagrams. We will show the next videos. Have a nice day.